Hello everyone. Today I'm going to make a presentation about virtualization, how it works a bit under the hood, and what recently did we get such tools on the Apple platforms. So let's get started. Quickly about me. So I'm an Apple developer at Proton VPN. Actually, we have also Proton Pass, which is a competitor to Dashlane. And yeah, this is me with some developer friends who are some of here in the room. Back in Dub 24 last year. So let's get back to the basics. So just first, because like virtualization is such a cool technology, first time I run like a virtual machine, I was amazed, like how can this computer run inside my computer? So as I said, let's back to the basics. Let's see what are the difference between a simulation, emulation, and virtualization. So just 1 moment, sorry, because I have my notes here. Okay, so simulations. So basically, it's a recreation of something that already exists, but it's a recreation, just like the iOS simulator. As its name implies, it's not an emulator, it's a simulator. So basically, you do not get the full thing. You have the illusion of an iOS device running with the Springboard and the apps that runs within it, but it's not a real iOS device. And obviously, you're missing a lot of stuff, such as, for example, Bluetooth. You cannot do Bluetooth on a simulator and lots of other stuff because Apple probably doesn't want to expose that much stuff within the simulator. But actually, you get kind of decent performance already with a simulator. Then you have emulation. So emulation, just doing a little bit of etymology, emulus in Latin, which means striving to equal, reviving. So yeah, basically we are making a software that tries to recreate an entire environment or a machine or something. So maybe you know like console emulators. Maybe you already heard about Dolphin, which is an emulator for the GameCube, or PCSX2 for the PlayStation 2. You have lots of other emulators, but also Android emulator. So on Android, you have something that looks a bit more closely to a real Android device. And with emulators, the target architecture, so we also say the guest, maybe not for emulation, but anyway, the target architecture of the thing you want to run may have an architecture that is different from the host. So like if I'm running like the Dolphin emulator, I'm trying to emulate a GameCube and the CPU is PowerPC. However, if I'm running on my Mac with an Apple Silicon chip, it's ARM64. So the architecture do not necessarily need to match. And for the PS2, same thing. This is a MIPS CPU. So yeah. And yeah, emulation is inherently slow because you have to translate every instructions to the host from the guest system to the host. But there are tricks to make it faster. We will see one in a few moments. And then you have virtualization. So yeah, virtualization is about running a system. So just like emulation, but the difference is that the target and the host architecture need to match. So if I have an Apple Silicon machine with an ARM64 device, I can run only I can virtualize only systems with the same architecture. Same thing if I have an old Intel Mac Intel, I can only run Linux Intel or Windows Intel. And so it's obviously faster than emulation because you do not have that much translation to make because the instructions are the same, almost. And it's even faster with hardware support. So like on your chips, like the Apple Silicon chips, you have extensions within the chips that makes the virtualization even faster. I will not dive into all the detail that make it faster because it's out of the scope of this talk, but it's really interesting, very complicated as well. But you have like specific instructions and features from the CPU that help to make a virtual machine run faster. Then another piece of software, sorry, hypervisor. So it's a fancy term to just say like this is the software that isolates the guest system within the host. So what do we mean by isolation? We mean that the virtual machine cannot inspect the resources from the host or from other virtual machines running on the same on the host, because you can obviously have multiple virtual machines running on your machine, but you do not want programs within the virtual machine to inspect and see what is running on the host or on other virtual machines. So the hypervisor, its goal is to control also the access to hardware resources, such as like any hardware that is connected to your machine, such as keyboards, mouse, or even GPUs. And yeah, so it's abstract. So the guest thinks it has dedicated hardware. There are two types of hypervisors. The type 1, which is called the bare metal hypervisor. So just to give you an insight, for example, I have a PC. I know, boo, I have a PC with a GPU, an NVIDIA GPU, because I wanted a good GPU. And I wanted to run a program within my Windows machine, but not within my operating system. I wanted to isolate it from my system. So I wanted to have it running in the virtual machine. So I installed Hyper 5, which is the Microsoft virtualization technology. And basically, I didn't even remember, but when I enabled it, I had to reboot my machine, because now when I boot my PC, the first thing that runs is the Hyper 5 hypervisor. And then what used to be my main Windows system is now virtualized within my PC. So it's really like optimized a lot, so that you almost don't feel it. But yeah, this is what is a type 1 hypervisor. A type 2 hypervisor is like same thing, a hypervisor, so same features, but it runs within like a host kernel. For example, on macOS, you have macOS kernel, and then you can have an hypervisor running thanks to the macOS already running on the machine. So on Apple platforms, what do we have? We have a new framework. It came with Big Sur, I think. So the virtualization framework. Basically, it's a high level to create virtual machines, a high level API, sorry. You just give it a configuration with like the hardware details, such as the CPUs, the memory, the peripherals, the storage, and that's it. You can run virtual machines like macOS virtual machines or Linux virtual machines with it, and it's written in Swift. So actually, the API is kind of easy to read. And unfortunately, you don't have a GPU pass-through. So if you want to run really intensive programs, you cannot do it with virtualization framework. At least from what I know, maybe they changed something within the latest WWDC. And this is why you started to see like lots of software such as UTM. Does anyone know UTM? Virtual machine, you have VirtualBuddy as well. You have lots of software now that pop up since this framework came out, because it's far more easier now to spin up virtual machines. Then you have a lower level framework, which is hypervisor for .framework, which is the thing that I told earlier. Now it's just available as a framework. So it's lower level, it's a C API. So you need to know how to write C. And actually, it's when you want to access like really deeper and configure your virtual machine with like a deep access to with an access to the peripheral. And also it runs in user space, so you don't need kernel extension, which is suitable for App Store distribution, which is nice. And yeah, this is needed when you want more freedom than virtualization framework, when you want really to go deeper. I will show you after a program that uses this framework. So just to recap, this is what we have on macOS. So as I said, you have the hardware, and you have like the macOS kernel that loads when you boot your machine. Then you have this hypervisor framework. Then on top, the virtualization framework, which just under the hood is giving you a Swift API to this hypervisor framework. And then you can run macOS virtual machines on Apple Silicon only, and Linux virtual machines on Apple Silicon and Intel machines. You cannot run macOS virtual machines on Intel Macs, but they're going to disappear anyway soon. So kind of related technologies. QEMU. Did anyone heard about QEMU? So yeah, it's really known software. It's made by Fabrice Bellard, a true genius. This guy, like, if there is a genius, is this guy. The amount of software that this guy put up is amazing. QEMU, it's him. FFmpeg, it's him. He made compilers. He made GIT engines. This guy is amazing. He has a record of pi digits. This guy is amazing. Anyway, he's French, so it's cool. And so yeah, back to QEMU. QEMU is a big piece of software that allows you to emulate operating system, virtualize those if, again, the architecture matches. And you have also a thing called user mode emulation, which is basically when you want to run like a program that is written in another architecture. Like you do not need to spin a full virtual machine. You just can run like I don't know, VLC, PowerPC on an Intel Mac or something. Lots of architecture support by QEMU, and actually lots of tools fall back to QEMU when they cannot handle it. So like, for example, UTM under the hood, if it can virtualize using virtualization framework, it does it. If it cannot, it just uses a QEMU under the hood. A little aparté about JIT. JIT stands for just-in-time compilation. So actually, this is also used by QEMU to have decent performance. So this is one of the tricks that I mentioned earlier that allows emulations to run faster. So JT, just-in-time compilations, is in contrast to AOT, ahead of time compilation. So when you write Swift, obviously it's ahead of time compilation. So you build it and then you run it. But JIT is all about generating the code and executing on the fly. So actually it's used in JavaScript engines and emulators to make it able to run fast, really fast. And on the iOS platform, it's only reserved to WebKits, unfortunately, for executing the JavaScript. And there are tricks to actually enable it for third-party apps, but I think it's patched in iOS 26, unfortunately, if anyone knows. But anyway. On macOS, you need very specific entitlements, and actually the real aspect on why Apple is such restrictive, at least that's what they say, on providing JIT for our apps, is that it's a security measure, and it's because to have JIT for work, you need to have writable and executable memory, which is disabled by default. Just because, as I said, you're generating code, so you need to write it to memory, and then you need to put this memory as executable to be able to execute it. So, and this is not enabled on iOS by default. Another thing, Linux containers. So actually, Linux container is kind of different to the term containers we use on macOS because it's kind of real containers. So this is a real feature of the Linux kernel. It leverages features of the Linux kernel that allows program to run isolated from the kernel host, but it does not spin virtual machines. This is really like a kind of program that are isolated and run in a container. And actually, this is a feature only available on the Linux kernel, not on macOS. And Docker, for example, is a good example of a tool that leverages this feature of the Linux kernel. And this is not the case on macOS. So maybe you did not know, but on macOS, Docker actually spawns virtual machines because there is no concept as of containers on macOS. Another tool that we use at Proton also, which is Tart. So it's basically a command line tool allowing you to spawn some virtual machines, macOS and Linux VMs. So again, it's written in Swift, so you can read the code and modify it if you dare, improve it. And yeah, you have really good performance because it uses the virtualization framework, which allows you to fully exploit fully exploit your machine. And actually, this is like kind of a snippet to have it running. Like you just have to brew install it, then you clone like a machine, so Sequoia, for example, and then you run it. So actually, I have a little demo because it's really fast to do, really quick. So I just need to run Tart run, and then Sequoia base, and then boom, you have a virtual machine that boots. So basically, just imagine that Tart is just a command line tool, probably using a Swift argument parser, and then it uses the virtualization framework to spin virtual machines. So well, kind of cool. I have other really cool demos to show you. Don't worry. This is just the beginning. So yeah, then another really cool stuff, nested virtualization. So when you want to run virtual machines inside virtual machines, why? To be honest, I don't know, but why not? Yeah, because it's possible, at least by the hardware, you can do it. Maybe it's used like by cloud infrastructure when they want to test really deep setups. But you can do it actually with the virtualization framework. You can do a nested virtualization. So it's officially supported since the M3 Max. So like, for example, this is my personal MacBook Pro, and this is only an M1 Pro chip. So I cannot do it if I try to use Tart and run a nested virtualization machine, it will say like, no, it's not supported. But this one is my pro MacBook and my professional MacBook. And this is a M3 chip, so I can show it to you. And yeah, but this is the official story. But to be honest, even the M2 has it. The guys that made Asahi Linux to install Linux on Macs so that the M2 chips can do it as well. So you can do on Asahi Linux a nested virtual machine if you really want to. But yeah, you need to install Asahi Linux. And yeah, for nested virtualization, it's only Linux VMs. You cannot do a macOS within a macOS within a macOS. So let's do again a little demo. So I can do Tart run Ubuntu. I need to precise. I think it's nested. Yeah. Oops. So like I have like an Ubuntu booting. And I think by default Tart just says admin. Okay, so now it boots. And then so I have like a Ubuntu live server ISO, and I have this little run script just to show it to you. Basically, it's just maybe you don't see anything, but it's just spawning QEMU, the software that I told you earlier. With like, it's an invocation that will just spawns a virtual machine. So if I just it's not finished. If I'm running bash run.sh, I have another virtual machine booting in my virtual machine. Cool. So this is only possible because this is an M3 Mac. So the virtualization framework allows it. So now it's running, it's QEMU that runs the virtual machine. And it's a bit long. Obviously, the performance are a bit not the best, but lots of stuff to start. Come on. Okay. And then I think I said Adam, and yeah, I have another virtual machine, my virtual machine. So I will just and again. Boom. So yeah, I don't know if it's useful to anyone, but you can do it. Next. But recently, what did we have like in the field of containers and virtual machines? There is this tool called Podman. Does anyone know it? Podman? Like it's just like a concurrent to Docker, like an alternative to Docker. And so I will not dive into the detail because I don't know even either what are really the differences between Docker. I think like, yeah, you can run Linux, so containers with no root privileges, whereas with Docker, you have to give it a root access. So there is Podman on macOS. It can run and starts VMs because again, there is no concept of container on macOS. And by default, it uses the virtualization framework. But since recently, maybe 1 year, they made another tool, which is libkrun. And actually, this is the thing that I wanted to start with. This is the reason I made this tool, because this tool, like, I was amazed by how impressive it is. So this is made by the same guys who made Podman. I think some of them work at Red Hat. And yeah, basically, it allows you to run what they call micro VMs. So really lightweight virtual machines that allows you to run process, but on isolation. Like it spawns a VM, just run that process and that's it. And so why did they made that? Because virtualization framework was too slow for them for such setups, for very specific setups. So they had to use the hypervisor framework under the hood in C. libkrun itself is written in Rust because it's performance and safety, so they wrote it in Rust probably. And the feature really cool that it allows you is GPU pass-through. So you can use like your virtual machine that uses under the hood the libkrun hypervisor kind of, will allow it to access the GPU of your Mac. And again, I will not really dive into the detail. This is thanks to something called Venus, which is, anyway, allows you to expose your GPU as a Vulkan device. Vulkan, for those that don't know, it's like metal, but better. And and yeah, it's perfect for applications using GPUs for gaming and high-end stuff. And what you just need to do is, like, within Podman, by default, it uses the hypervisor, the virtualization framework, but you can, within the configuration file, say just use libkrun, and it chooses libkrun. But recently, Apple gave us the container tool. Maybe you saw it since the WWDC 25. Actually, this is the only session that I saw. I didn't even watch the platform State of the Union yet. But when I saw that, I said, oh, I need to make this talk. So this is like kind of a competitor again. It's open source. It's written in Swift. It's totally new. So it's based, actually, the container tool is just like a command line tool that uses under the hood the containerization framework, which is also open source and allows you to manage your containers and images, containers and stuff. Each container runs inside its own lightweight machine. So again, I think they stole a bit, I don't know, the concept of the guys who made libkrun. And actually, it's better for the security because, like, before you had one big virtual machine with containers within it, and now you have like a virtual machine per container, so you can map resources from the host to the virtual machine just to the one that needs it. And yeah, by having the lightweight virtual machine, you can strip what is not needed. And they say like it's better for network performance. I don't know, I didn't test extensively, but let's trust Apple. And so, yeah, basically, this is a slide I stole from the presentation. This is what we had before. So you had like your macOS running on your Mac, then you spawn up a Linux virtual machine, and then you could have multiple containers within it. So this is probably the setup that Docker uses. And now with their tool, container tool, you have the macOS again kernel, and then you spin a virtual machine with a container by virtual machine for every virtual machine. So again, let's do a demo. So this one will be really tricky. So the goal is to show the differences between the container tool and the libkrun tool. And this will be like really, really hard because I installed it on this Mac, which runs Tahoe, because the container tool can run on Sequoia, but they said like on the latest macOS, but they said like it runs better on Tahoe. So I will just connect using VNC. Let's hope that it works. Okay. 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 So let's go to the container stuff. So this is like using the Apple, what Apple recently announced. Come on. Ah, sorry, it's hard to type with one hand. Okay, and then so get the come on. Okay. Okay. So actually, I spent like like an evening, like until 2 a.m. in the morning, just reading this stuff with the container framework, so the container tool by Apple, and I saw some bugs already, but maybe I will make an MR, I don't know. And what we'll do is just like run a virtual, so a container, what they call a container, and run like a model with lambda.cpp, if you know it, and we'll do inference and see how it compares in terms of performance to libkrun. So I will run also activity monitor. And what I want you to pay attention to is here, just don't pay attention to all the processes, just here like the user percentage. So okay, so you need to do first container system start. Okay, and then, so this is using the Apple tool. So now I have like, what is it again? What I choose Fedora, so the Fedora. So I have like the file system of a Fedora virtual machine. And then I will run, so the Llama tool that I built, and I'm going to use the Mistral 7B model and just ask it, tell me a very short story. And if I run it, so this is the container tool, and there is no GPU pass-through because this is not libkern. Libkern allows it, but not the Apple tool yet. So if I run it, again, pay attention to the user CPU here. So it's not running again already, sorry. Okay, now it's running, and now like you can see, like here, the CPU goes up, so to sometimes at 70%. So, but anyway, just to show that it uses the CPU. Well, actually, it was kind of fast already, but when I first ran this, I was expecting far slower speed. But just to show also, if I run Vulkan info -- summary, here it shows like only one Vulkan device, which is the CPU. I didn't even know, but yeah, using what they call LLVM pipe, you can use your CPU as a Vulkan device. Now let's just exit this and go to the libkern. I think so almost the same feeling, unless here it's using Podman. And so I didn't show the content of the run script, but it's basically just launching Podman. But this machine is set to use the libkern hypervisor. And then if I just first, if I do again Vulkan info, so here you can see there are two GPUs in like this one called Venus, which is the GPU of my Mac, and yeah, thanks to magic, kind of. This is seen as a Vulkan device, even though Vulkan is on macOS. It's not. I can do Vulkan on macOS, I think. But anyway, and if I run the scripts, so it's the same thing, just running Llama inference and asking him, tell me a very short story. Here, normally you will see like the CPU usage will just stay classic, and here, so it stays at 6%, the user CPU usage. And here now it uses the GPU. So basically, a virtual machine and libkern, thanks to the hypervisor framework, allows it to access the GPU on the host on my Mac. And yeah, you can do inference using models, you can do games, anything within virtual machines. So that's it for this demo, which is done using VNC on this Mac actually, even though this is this Mac presenting. And that's it for this presentation.
Thank you. It was very Inception. It's not a dream in a dream, it's a VM in a VM in a VM
Yeah.
in another VM. There you go.
Thank you so much. Always. Thank you. Always super interesting to listen to you. I was just wondering. Everything's falling down. I was just wondering because I'm big on server-side Swift and I love Vapor and Hummingbird and all that stuff, and I was just curious to hear whether you thought that there was opportunity for these frameworks because today they use Docker. I was curious to know if they could make use of these technologies so that one day in the near future we can run Swift code within a VM built with Swift code and stuff like that.
Yeah, I think this is definitely what they had in mind when they came up with this container tool. It's to support like and give facilities to the Swift on server ecosystem and tools. So like actually the container tool is already kind of compatible with Docker files. So you just write a classic Docker file, just like Podman, by the way, also. But yeah, container tool, just give it your Docker file that it builds the image. Then you have an image and you can spawn it. And if you configure it to have Swift running on it with the Vapor framework installed, then it should run and you benefit from all the isolation provided by the VM. Obviously, we don't need all this setup with libkrun. This is only when you want to do some really tricky stuff using a GPU and stuff, but using the classic container stuff tool, you can already do that.
Thank you. I didn't have time to watch the WWDC 25 video about containers library, but is the GPU support coming soon? Was it announced or nothing was said?
They didn't announce anything. I think since the container, I don't know yet what the containerization framework, because there is a container tool which uses under the hood the containerization framework. I think they probably use virtualization framework. I need to check. Maybe someone already checked, but yeah. So, and the virtualization framework, as it stands right now, I think it doesn't have GPU pass-through. You need to go to the hypervisor framework and expose it, because from what I've heard from a presentation from the guys at Red Hat that made the libkrun tool, this GPU pass-through was not the only reason they wrote it. Actually, so if you want to go into the details, there is this specification called Virtualization, which allows to access virtual machines to resources on the host. This is called para-virtualization. So para-virtualization is just like let's cooperate the host and the virtual machine to access the hardware. And this Virt.io is a specification allowing you to have this cooperation to access the memory, the file system, the GPU. And actually, even the Apple implementation of Virt.io file system is not up to what they wanted. So they wrote libkrun, and they wrote their own Virt.io stuff to have like a better support, because apparently Apple does it their own way as usual. And yeah, they wanted to have better integration.
Thank you.
Merci.